Hello my students, today in this video I am going to explain about rate of reaction, rate law and order of reaction from the chapter chemical kinetics. So first of all, what is rate of reaction? Rate of reaction is the speed at which the reactant is converted into product. So it is expressed in terms of the disappearance of the concentration of reactants with time or appearance of product with respect to time. So first of all, expression of rate for a balanced chemical reaction. Okay, suppose this is a balanced chemical reaction. AA plus BB gives CC plus DD. Small letters are their stoichiometric coefficients, while capital letters are reactants and products. For this particular balanced chemical reaction, rate is expressed in terms of the concentration disappearance of these reactants and these products. Okay, so first of all, rate of this particular reaction is expressed in terms of concentration of this reactant A, that is minus delta A by delta T, so this delta A is the change of concentration of reactant A and delta T is the change in time, and this term minus delta A by delta T represents rate of disappearance of the reactant A. Okay, and if we divide this rate of disappearance of A by its stoichiometric coefficient A, then we will obtain the rate of this particular reaction. Rate of this particular reaction is represented by small r, and this minus delta A by delta T represents, this term represents rate of disappearance of the reactant A, and if it is divided by its stoichiometric coefficient A, then this whole term will be equal to the rate of this particular reaction. Okay, in terms of the concentration of reactant B, this is the rate of this particular reaction is equal to minus delta B by delta T multiplied by 1 by B. B is the stoichiometric coefficient of this particular reactant B, and again this term represents rate of disappearance of the reactant B, and if it is divided by this stoichiometric coefficient B, then this will give the rate of this particular reaction. In terms of concentration of C and D, this is represented by delta C, this is capital C, and delta C divided by delta T into 1 by C, this is small c. Okay, this is capital C and this is small c. Okay, similarly in terms of the reactant D, the rate of this particular reaction is equal to delta D divided by delta T into 1 by D, and here this delta C, this is C not E. Okay, this looks like E. This term delta C divided by delta T represents rate of disappearance of the reactant C. Okay, and this is also called rate of formation of the product C, and this rate of formation of C is divided by its stoichiometric coefficient small c, then we will get the rate of the reaction. Similarly, this term is rate of formation of the product D. Okay, I'm taking an example here as a question. Here the reaction of Haber's process is given 3H2 gas plus N2 gas gives twice NH3 gas. Now the question in this particular reaction is, write the expression of the rate in terms of concentrations of the reactants H2 and N2 and products NH3. This is the first question. Second question is, if the rate of disappearance of H2, if the rate of disappearance of H2 is the reactant, right? If the rate of disappearance of H2 is 2 into 10 power minus 4 mole per liter per second. Mole per liter per second is the unit of rate of reaction. Okay, and one thing I have missed to tell you about is why this negative sign is placed. Actually, this negative sign is placed because rate cannot be negative. Since this delta A is change of concentration of reactant A, suppose this is the diagram. Suppose this is the diagram of concentration versus time. Okay, then reactant concentration will decrease with respect to time, like this. And if I take some 2 times here, this is time t1 and this is time t2. Suppose at time t1 the concentration of the reactant A is suppose A1, and after time t the concentration of the reactant left will be represented by A2, and it is clear from this diagram that A1 is greater than A2. But when we calculate delta A, which is the concentration change of the reactant A, this will be equal to A2 minus A1, final minus initial. And since this A1 is greater than A2, this term will give a negative value, because smaller minus bigger gives a negative value, and this delta A is going to be a negative value. And if I do not place this negative sign over here, then rate would have been a negative value. So multiplying this negative by this negative value of delta A, negative will become plus. So this negative sign is placed because rate cannot be negative. Okay, now let us come to the question. If the rate of disappearance of H2 is 2 into 10 power minus 4 mole per liter per second, calculate the rate of the reaction R. We need to calculate R, and the rate of disappearance of what? The rate of disappearance of this is going to be N2, and rate of formation of NH3. Okay, so let us move to the answer section. This is the answer I have already calculated. Let me explain here. For this reaction, twice, let me write this reaction, 3H2 plus N2 gives twice NH3. The expression of rate will be equal to R, it will be equal to minus delta H2 by delta T divided by this stoichiometric coefficient 3, and in terms of the reactant N2, this will be equal to minus delta N2 by delta T, and in terms of the product NH3, this rate will be equal to minus delta NH3 divided by delta T multiplied by 1 by 2. 2 is the stoichiometric coefficient of NH3. So it is also clear from this expression that in terms of concentration of reactants H2 and N2, there is negative sign in the expression. This is negative. Okay, now this is the answer of the first question. This is the expression of rate. Now to us the given is the rate of disappearance of H2, that is 2 into 10 power minus 4. Okay, so to us the given part is minus delta H2 by delta T. This part is given to us, which is equal to 2 into 10 power minus 4 mole per liter per second. So we are going to calculate the rate of this reaction, that is R, and R is equal to this whole rate of disappearance of H2, which is given by 2 into 10 to the power minus 4 multiplied by 1 by 3 or divided by 3. So this gives this value, which is the rate of this reaction. Okay. And the second part we are going to calculate is rate of disappearance of N2, and from this expression rate of disappearance of N2 is equal to the rate of the reaction. So rate we have already calculated here, so this is equal to 0.67 into 10 power minus 4 mole per liter per second. The third part of the question is to calculate the rate of appearance or formation of NH3, delta NH3 by delta T. So from this expression delta NH3 by delta T will be equal to, since this is divided by 2, so this 2 will go over here. So delta NH3 by delta T will be equal to 2 times of R. So delta NH3 by delta T is equal to 2 times of R, and 2 into R is 0.67 into 10 power minus 3, and this is equal to this value. Okay, 1.34 into 10 power minus 4 mole per liter per second. Okay, I hope you get this question. Let us move to the next part of this video, that is rate, law and order of the reaction. Rate, law and order of the reaction. This is rate, law and order of the reaction. Now rate law of this reaction, of any balanced chemical reaction, states that the rate of the reaction, the rate of the reaction is equal to the product of the concentrations of reactants each raised to the powers equal to some numbers which are determined by experiments. This is the expression of rate law. Rate of a particular reaction will be equal to the product of the concentrations of the reactants each raised to the powers equal to some numbers which are determined by experiments. Suppose this is the balanced chemical reaction, AA plus BB gives product, and the capital letters A and B are the reactants, while small letters small a and small b are their stoichiometric coefficients respectively. Okay, so according to the rate law of this reaction, according to the rate law of this reaction, rate R is directly proportional to concentration of the reactants, means A is the reactant, B is the reactant. Okay, so concentration of reactant and concentration of reactants A and B is represented by this square bracket A and square bracket B. So product of the concentrations of the reactants, and to each term will be some numbers that are determined by experiments. So here small a does not come here, small b does not come here over here. Okay, so this n and small m are some numbers which are determined from experiments. So this small n is called order with respect to the reactant A, n is order with respect to A, and the small m is order with respect to the reactant B. Okay, and order of this particular reaction will be equal to n plus m, sum of the powers of the concentrations of the reactants in the rate law. This is the rate law expression. Okay, and if this directly proportionality is converted into equality, there is some constant term small k, and this small k is a constant of proportionality, and it is called rate constant or velocity constant or specific rate of this particular reaction. Okay, so this is the expression of rate law. and this n can be equal to this small letter a, but generally they are not equal. Okay, and this n and the m can be known only from experiments, not from the balanced chemical reaction. Suppose if I am saying this reaction 3H2 plus N2 gives twice NH3, this is a balanced chemical reaction, and we cannot say the order with respect to this hydrogen is 3, because its order is not 3 actually. This is just the stoichiometric coefficient. Okay, and the order with respect to N2 is also not equal to 1. Order of this reaction is not equal to 3 plus 1, that is 4. Order of this reaction is not equal to 4. Okay, so the order with respect to hydrogen and order with respect to nitrogen, they are determined from experiments only. Okay, so order is an experimental term. Okay, let us move to the next part. This is some examples are given here. I have written here A is the order, and the N plus M is the overall order of the reaction. So order, definition of order is here. Order of a reaction is defined as the sum of the powers of the concentrations of the reactants in the rate law expression. Okay, that is N plus M is the order of the reaction. Okay, now I am giving two examples here. The first example is of a reactant only. A gives product, for example, and for this particular reaction we cannot say the order of the reaction is 1. If the rate law of this reaction is written like this, R is equal to K A to the power 1, then this 1 is the order of this reaction. Order of the reaction will be equal to 1. And if the rate law of this particular reaction is written like this, which is from experiment actually, I am using the word if. Okay, if the rate law of this reaction is R is equal to K A to the power 2, then order of the reaction will be equal to 2. And if it is written like this, R is equal to K A to the power minus 1, then order of this particular reaction will be minus 1. And if it is written like this, R is equal to K A to the power 3 by 2, then order of the reaction will be this 3 by 2 only. Okay, so from this it is also clear that order can be a positive value, it can be a negative value, it can be a fraction, or it can be 0 also. Okay, order can be anything. Okay, now let us move to the next example. This is the next example, second example. This is the second example, which is for two reactants A and B, and their stoichiometries are 2 and 3, for example. Okay, so if the rate law of this particular reaction is given like this, R is equal to K A B, then order with respect to the reactant A will be 1, order with respect to the reactant B will be 1, and order of this particular reaction is equal to 1 plus 1, that is 2. Okay, and if the rate law of this particular reaction is written like this, R is equal to K A B to the power 2, then order with respect to A will be 1, order with respect to the reactant B will be 2, and overall order of the reaction will be 1 plus 2, that is 3. Okay, and rate law, if the rate law is R is equal to K A to the power 2 B to the power minus 1, then order with respect to reactant B will be minus 1, order with respect to the reactant A will be 2. So overall order will be 2 minus 1. 2 minus 1, that is 1. And if it is okay, now one important point here is this expression can be written like this: R is equal to K A to the power 2 divided by B, concentration of B, right? So rate is inversely proportional to the concentration of the reactant B. When the concentration of reactant B increases, the rate of the reaction decreases. Such substances which decreases the rate of the reaction is called inhibitor. So B here is acting as inhibitor. Okay. Now let us move to the next part of the video, that is definition of rate law, a rate constant. Rate constant K is defined as the rate of the reaction. If the rate law of this of any reaction is written like this: R is equal to K A to the power n is the order of the reaction. And if it is written like this also, R is equal to K A to the power n and B to the power m, order of the reaction would have been n plus m. Whatever the expression of the rate law, this K, which is the rate constant of the reaction, will be equal to rate of the reaction, R, when this A, concentration of A and concentration of B are 1 molar. Then only K will be equal to R. So K will be equal to R when concentration of each reactant is 1 molar. So rate constant is defined as the rate of the reaction when concentration of each reactant is 1 molar. Okay. Next is unit of rate constant, K. Unit of rate constant, K. So if the rate law expression is R is equal to K A to the power n, where the n is the order of the reaction, K will be equal to R divided by A to the power n. So unit of K will be unit of R divided by unit of A to the power n. Unit of R is mole per liter. This is mole per liter, like this, and per second is there, and unit of concentration is mole per liter, and to the power there is n, right? So this is equal to mole per liter to the power 1 minus n. This is 1, okay, 1 minus n per second. So for first order reaction, n, where n is the order of the reaction, okay, n is equal to 1 for for first order reaction, n is equal to 1. So unit of rate constant K will be per second, because 1 minus 1 will be 0, mole per liter to the power 0 will be equal to 1. So unit of rate constant for any first order reaction will always be equal to second inverse or meter inverse, like that, minute inverse, For second order reaction, n will be equal to 2. So unit of rate constant will be mole per liter to the power 1 minus 2, which is minus 1 per second. So minus 1 multiplied by minus 1 gives 1 liter, and mole power of mole will be minus 1. So liter per mole per second. For third order reaction, n is equal to 3, so liter square per mole square per second. And for zeroth order reaction, n is equal to 0. So here when we substitute n by 0, then mole per liter per second. So mole per liter per second is also the unit of rate of the reaction. So for zeroth order reaction, unit of rate constant, unit of K will be equal to unit of R. Okay, this is true only for zero order reaction. Okay, now let us move to a question which is from NCERT exercise at the end of the chapter, but I have given 3 questions from that particular one question. Suppose the reaction is twice A. The reaction is twice A plus B gives A to B, and if the rate law of this reaction is given by this expression, R rate is equal to K A to the power 1 B to the power 2, where the value of K, that constant, is given as 2 into 10 power minus 6 liters square per mole square per second. So the questions are, what is the order of the reaction? First question. Second question, calculate the initial rate of the reaction when A is equal to 0.1 mole per liter and B is equal to 0.2 mole per liter. So we need to calculate the value of R. This is rate is R when concentration of A is 0.1 and concentration of B is 0.2. And the third part of the question, which is very important, very good question. Calculate the rate of the reaction after A is reduced to 0.06 mole per liter. Initial concentration of A was 0.1 mole per liter. When the concentration of the reactant A is reduced from 0.1 to 0.06, at that time we need to calculate the rate of this reaction. Okay, so the third question is a good question. So let us move to the answer. So this is the red law which is given in the question itself, and order of the reaction will be equal to 1 plus 2, 1 plus 2, 1 plus 2, which is 3. So this is a third order reaction, which is also clear from the unit of rate constant. Okay, so moving to the second part of the question, we need to calculate R when A is 0.1 and B is 0.2. So after substituting the values of K, A and B in this expression, equation number 1, then we get the initial rate of the reaction, which is equal to 8 into 10 power minus 9 mole per liter per second. Now let us move to the next part of the question, last part of the question, which is very important. When concentration of A is reduced from 0.1 molar to 0.06, the concentration is decreased by 0.08. 0.1 minus 0.06 is equal to 0.04. So the decrease in concentration of reactant A is 0.04. Now again, moving to the balanced chemical reaction, this is given in the balanced chemical reaction. Twice A plus B gives A to B. When mole of reactant A is 2, mole of reactant B is 1. Means when 2 moles of reactant A is converted into product, only 1 mole of B will be converted. Okay, so when the decrease in concentration of reactant is 0.04, 1 is the half of 2, right? 1 is the half of 2. So when concentration of reactant is reduced by 2, concentration of reactant will be reduced by 1. This is 1 is the half of 2. So when the concentration of reactant is reduced by 0.04, the concentration of reactant B will be reduced by 0.04 divided by 2, which is 0.02 only. This is the reduction in the concentration of the reactant B. So concentration of B will become from 0.2 minus 0.02, which is equal to 0.18. So now we are substituting the value of A by 0.06 and B by 0.18 in this red law expression. We get 2 into 10 power minus 6 the value of K, rate constant, which is given in the question, and the concentration of A will be 0.06 and concentration of B will be 0.18, and there is a square, and after calculation we get this value 3.9889 into 10 power minus 9 mole per liter per second, which is approximately equal to, you can say, 3.9 into 10 power minus 9. Okay, so this is the answer of the third question, 3.89 or 3.9 into 10 power minus 9 mole per liter per second. Okay, now this is the topic that will be explained in the next video. For today, I'm finishing this video over here, and if you like this video, please share to your friends and groups, and if you are new to the channel, please subscribe to the channel. Thank you.